So in the previous class we saw these two protocols. Number one is the TLS, Transport Layer Security. Transport Layer Security. And then other one is the Datagram Transport Layer Security. The Datagram Transport Layer Security is based on the TLS only. So TLS and DTLS both are secure. They're equally good. But DTLS protocol provides communication privacy for Datagram protocol, meaning UDP protocols. It is based on the TLS protocol. Which one? DTLS is based on the TLS protocol, which is a protocol that provides security to computer-based communication network. That's what I was saying yesterday. We don't see this much in the networking world, TLS and DTLS. You might have seen in end host like server. But here we are seeing, because this is for the controllers within a LAN, like end host device, like a computer. To provide security between the for the communication that is happening between the vManager, vSmart, vBond, between this controller, this protocol is needed. Not only that, the edge device will also use this DTLS initially till the edge device identify the vManage and vSmart with a vBond. This DTLS will be the protocol. It is the DTLS tunnel that is established between the edge device and the vBond. What are the three controllers we have? Someone tell me, what are the three controllers we have?
vManage, vBond, vSmart.
Very correct. What is the purpose of vBond?
Authentication.
Just for authenticating the V edge or a C edge or any WAN edge. After that?
Provide the information about vSmart and vManage.
vManage provides the IP address or the fully qualified domain name
FQDN, yeah,
to reach the vManage and
vSmart.
After that, there is no need for vSmart. There is no need for vBond and vEdge communication if there is no NAT traversal involved. But if NAT traversal is there, then there is need for the vBond to interact. See, what is NAT traversal? If you have an edge device here, and you got a router here, this router is connected to the WAN. The edge device is not directly connected to the WAN. Likewise here also you got a router, and then you got an edge device. So the public IP address is here. Again, the public IP address is here. So can this edge ping this edge? No. Without netting, it's not possible. This is in private. So there is a need for the translation between this private to public, inside local to inside global. Likewise here, inside local to inside global, there is a need for translation, and vice versa. Outside global to outside local, and so on. We call it as NAT traversal. when your edge device is not directly facing the WAN, when your edge device is not directly connected to the public, VBond need to be always referred for this NAT traversal to happen. So only in that case the DTLS connection establishment.
If it is a static NAT, also sir, always communication needed?
Yeah, you need it. You need it. And then this VBond can also be behind a router.
Then in that case, VBond should be netted.
Yeah, but it needs to be one-to-one netting. If you can keep it as public, it is good. But if you don't have an option to keep it as public, then it needs to be one-to-one netting. In this case, only when you have edge device behind the edge router, you will need this VBond connection to remain connected. Otherwise, when we don't have this router here, which means the edge device is directly connected to the WAN, public, there is no need for NATing. In this case, there is no need for this tunnel after edge device discovering the vSmart and vManage. Yeah, we learned this yesterday. This is not new. We just learned. We learned it yesterday and we just revised it. Now more about vEdge. Let's see more about vEdge today. So if you see vEdge, that is web tailors. But Cisco tries to promote their own device, cEdge. Cisco 1000, CSR 1000 V. This is one of the cEdge. Likewise, ASR 1000 is also there. See, there is an operating system which is iOS XE 17.2.1 and later version. Which is considered to be a universal image. This operating system is an universal operating system, meaning this can be installed on any CSR device. But check the compatibility before you install. What it means is it supports the SD-WAN feature. So if this image is available for you, and if this image is having the proper license and so on, it's an universal image. There is no limitation. You may use that CSR 1000V with this image or the later image as the vEdge device, sorry, cEdge device, Cisco Edge device. But if you are using this image, the universal image, I said universal image, when you are using this universal image, the SD-WAN controllers, when we say SD-WAN controllers, the three controllers, vManage, vSmart and the VBond, should be at least need to be at least, minimum requirement is it needs to be at least 18.3.0 version minimum. When you want to use this image, the universal image on CSR device, and now the CSR device will be the CH device for you. To interact with this universal image, the controller need to have at least this version, not older one, at least this or later one. Now what's the advantage of using Sage? It's a Cisco device, right? Because it's a Cisco device, along with the BGP and OSPF, you can also have EIGRP. You cannot expect EIGRP support from VEdge, WebTail. You will have OSPF, you will have BGP, but no EIGRP. If you have Sage, you have the advantage of using EIGRP also. I'd like to show some VEdge device. So if you see here, this is the wireless VEdge. These two are gone actually. This is base, see 100 VEdge 100B. VEdge 100B, B means base, Ethernet only. It's end of sales already. Likewise, Edge 1000M, which is modem, that is also end of sales. They say 3 different flavors. The third flavor is W. The W is not listed here, they have removed it, but the third one is W. And this W is what you see here, the wireless. These are all end of sales now. Even this one is end of sales. VEdge 1000 is end of sales. We do have 5000. We have ISR, all of this. And then VEdge, this is what just now we spoke, 1000 VCSR. In ISR, you have ISR 1000, ISR 4000. ASR also you have 1000 series. We also have ENCS 5000. This is the enhanced capable switch. It's a switch which runs iOS XE, which is specially designed with the software that can support SD-WAN. So you can see this one is used in a home office, small office, home office. This is used in normal enterprises, kind of little bit bigger. This is used in a very big office, very big WAN setup. You can see the capacities, the variations in the memory and so on. So a lot of things you will see. I'll just put this link for your reference. So we saw the different V edges or C edges or WAN edges options that that Cisco provides us as an edge device. Now next is this vSmart. How do you draw vSmart? You know, vSmart. Oh, a lot of brain.
Sir, sorry. Can I get a quick recap of what EIGRP is?
Enhanced Interior Gateway Routing Protocol. It's the routing protocol that is used to advertise the routes, like RIP routing protocol, EIGRP, OSPF, ISIS, BGP. They're all routing protocols. Enhanced Interior Gateway Routing Protocol. It's a routing protocol. Okay, so vSmart is not a physical device actually. vSmart is a virtual. It's a VM. It's a VM. It can be deployed in a private cloud, or it can be in your own premises as a VM in a virtual environment. So this is a virtual device. It's not a physical device. Again, about the vSmart, you know what is vSmart, right? Are they in the data traffic path? No. So no data traffic goes through this vSmart. No, it's not a data plane device. So no data traffic. No data traffic through the vSmart. Next is this is a device which is not the part of data vEdge. See, vEdge is a data plane. So for vEdge, vSmart is out of band. vSmart is out of band, OOB, out of band to the vEdges, to the edges, to the edges, to the edges. What does it mean? It is not sitting right inside the edge. It sits outside the edge and controls the edge. If you take a normal router, where is the control plane? Inside the router. But here, where is the control plane? Controllers, they're outside. So this is one of the outbound device to the edge. You don't sit on the edge environment. It is outside, out of band. Now, what is vSmart Exchange? They exchange the route information to and fro. So vEdge has got some local policy. vSmart has got some global policy. All those that are for the global policy, all those configurations that is for global policy will be pushed by vSmart to the vEdges, will be distributed by the vSmart to all the vEdges, because it's global policy. The local policies are directly given by vManager to the vEdge. Please try to understand what I'm saying. vManage will push the necessary configuration using netconf directly to the vEdges, only those that are local to vEdge, only those that are local to the WAN edge device. So to the WAN edges, not all configurations are pushed by vManage, only the local policy to that WAN edge. But those that are common for all edges, those policies that are common for all edges that are configured by you on vManager is pushed to vSmart, and vSmart only propagates it, distributes it to all the edges. So using TLS and DTLS back and forth, between the vSmart and vEdge, the informations are exchanged. Repeating again, the informations are exchanged between the vSmart and vEdge back and forth using TLS and DTLS. Now, sometimes we may need more than one vSmart. Tell me why we need more than one vSmart. Sometimes we may need more than one vSmart. What may be the reason?
Redundancy purpose.
Okay, any other reason? The size of the network is too big. So depending on the size of the network, we may have more than one vSmart. All the vSmart will be active, and it will have TSL and DSL connections to every edge device. Very important. Let's say I have 5 vSmart. All 5 will be connected to all edge. All 5 will have active connection. It is not active standby. All will be active. With all the vSmart, the edges will have TSL and TLS and DTLS connection. Yeah, so that's about vSmart. Let me repeat. vSmart is a virtual device. It can be in a private cloud or it can be under the virtual environment. vSmarts are not a data plane. They are out of band to vEdge, or they are out of band to edge device, meaning they are not a data plane. No traffics pass through the vSmart. The responsibility of vSmart is to exchange the global policy informations, the global route policy informations, global route informations, exchange the route informations to and fro using TLS and DTLS between vSmart and vEdge. And depending on the size of the network, we may have more than one vSmart. When we have more than one vSmart, they are not like active standby. All will be actively establishing the TSL and TLS and DTLS connection with every edge device. Very important. Next in our list is vEdge. Next in our list is vManage. Now, before we go to vManage, I think we need to have a quick kind of recap. You see, we got a vManage. This is how we draw vManage. This is how we draw vManage. On the vManage device, we configure the policy. We configure the policy for every edge device, for every sites. And now, using the netconf, the policies are pushed via the netconf to the vSmart. Yeah. So what is netconf? Netconf is a protocol. It's an XML based protocol. Which will use SSH for transport. So it's a secure transport mechanism. In a secured way, all the configurations that you did using the graphical user interface on the vManage is pushed in a secured way in an XML format to the vSmart device. And this vSmart pushes the information to the vEdge and cEdge. Yeah. So between the vEdge and cEdge, the vSmart push the information, the policy information, via using the TLS connection. I say no. The TLS connection TLS and DTLS connection will be there with all the vManage and with vManage and vSmart from the edges. So using the TLS connection, just pushed. And now what happens? The necessary configuration for this device is now downloaded. Now according to the policy, cEdge will now advertise the transport locator. You remember transport locator? Yesterday we learned this, which will have the next hop based on the color, type of connection, and so on. So the TLOC information will be advertised by the vEdge, and this vSmart will distribute it to all other vEdges. So vEdge will push the TLOC information to vSmart, and vSmart will exchange the TLOC information to and fro to all vEdge using what protocol? OMP. This is where OMP comes into picture. So OMP is managed by vSmart controller. See, let me repeat the story from the beginning. You do all the necessary configuration only from one place called vManage. Using netconf, some configuration comes straight to vEdges. Some configuration goes to vSmart. What protocol is used here? Netconf. The configuration that comes to vEdge is local to that vEdge. Whatever is local to this router, that comes directly. Whatever is global for all the edges will come to vSmart. And vSmart will use that connection, TLS connection, which is already established, and push the configuration, the global configurations. And after collecting all this route policy information, both from vManager and vSmart, this knows now what all routes I have for various destinations and what will be the next hop, all based on the policies. That is what we called as transport locator. How I am going to go, which WAN is the preferred WAN to go to which destination. So that is taken by vSmart and distributed to all other V edges. Like this will advertise its T-log, that will be distributed by vSmart to the other edge using OMP, Overlay Management Protocol.
So T-log will help to distribute the traffic, distribute the routes?
No. T-log is OMP is the one which is distributing. T-log is the route information itself. T-log is policy-based routing is what T-log. Previously we learned that T-log tells which next hop I need to take to go to destination. For this destination, this is the next hop. That is identified with the three components. One, the system IP, which is equal to the router ID. And then the tunnel color, means the preference. And then the encapsulation type. So for each WAN circuit, you will have one T-log. Depending on the policy, a path will be taken. See, if I have two routers, see this example is very nice example. There is one edge device, there is another edge device. There will be 4 tunnels if I have 2 routers. One is internet, another one is WAN. So from edge 1 to edge 2, there will be 2 T-logs, or 2 tunnels, one via the internet, the other via the WAN. Likewise, edge 2 to the edge 1, there will be again 2 tunnels. That's what it means. For example, there will be 4 tunnel connections attempted between 2 routers that have two internet WAN circuits by default. So there will be 4 tunnels. It's 4 different policy. So 4 tunnels. So T-log is simply
basically
policy-based path selection.
And based on this policy, then
OMP carries it.
Yeah.
Fine. The next is VBON.
If that OMP, because there's just the policy, OMP will do that. So where basically exactly our underlay protocol will work. When?
Our underlay protocol is taken care by the ISP. You don't need to worry about it.
No, still my same device.
Your LAN protocol will not run on SD-WAN. SD-WAN has got its own protocol, OMP, to carry it.
Correct, sir. But before SD-WAN, let's say, I have my BGP network.
BGP will carry it. You need to redistribute. You need to advertise all the routes to the service provider. And service provider, by using the VRF routing table, he takes it and puts it into the MPLS VPN tunnel, or he uses BGP to distribute to the other PE. So it will be taken care by BGP or MPLS on the service provider side. Whereas in SD-WAN, we never advertise any routes to any service provider. We have our own OMP.
But sir, if you remember, if you said, because the basic reachability should be there.
Basic reachability for what? Basic reachability for VH to know where is VBON. After authentication, when VBON gives an information, based on that information, I need to go and reach that vManage and vSmart. For that, the public reachability need to be there. But that is not the one which will be encapsulating my packet. No encapsulation, no tunnel business here. We don't have that underlay address in consideration. See, if we would have done MPLS, then this doubt would have not come. But I'm trying to explain you, if no SD-WAN, all the networks of Edge 1 need to be advertised using BGP or OSPF or some protocol to the provider. Provider will take it and transport it, advertise it to the next provider. That is how it goes.
That I understood, sir. Let's say I am advertising over internet or MPLS, my private network. Let's say I, as you said, that my VH is let's say core, then VH. My design is something like that, core VH, and then my MPLS router, that is customer's edge router, and it has a pairing with the E router. That's not my lookout. That becomes service provider router. Now I am running BGP from this location, scope locations to hub location.
No, we don't run BGP in SD-WAN like that. It's only without SD-WAN. When you don't have SD-WAN, you will do all those stuff. Here, no, nothing like that.
Okay. Now tomorrow, if I have my SD-WAN network been deployed, sir, if I want to advertise new subnet, so in that case, where I need to advertise?
Nothing. You just go to vManage and say this is the network that I want to advertise to these edges. Accordingly, the policy will be pushed, and vEdge of this site will advertise, and the other sites will learn it.
So I don't need to advertise on the underlay protocol.
No. We don't do that.
Okay.
All right. Fine.